An asteroid, named Fritillaria, may collide with our Earth on September 24, 2182, and according to the recent prediction of NASA, the probability of this Bennu asteroid colliding with our Earth is as high as 1 in 1,750. The average diameter of this asteroid is 492 meters, which is about the size of the Tokyo Skytree, the tallest self-supporting steel tower in the world. Once the Bennu asteroid collides with the Earth, it could release 24 times as much energy as the most powerful nuclear weapon ever built, reaching 12,000 megatons. Will the Earth survive the impact of Bennu asteroid? Has NASA taken corresponding measures to prevent or mitigate the occurrence of such impacts? Today, we will reveal from a scientific perspective. Will our Earth really suffer from the impact of Bennu asteroid in the future? If the Bennu small star needle hits the Earth, what unimaginable consequences would it bring to our living environment? First of all, asteroids are rocky remnants formed when the solar system was formed 4.6 billion years ago. Most asteroids come from the main asteroid belt in the solar system. This asteroid belt lies between Mars and Jupiter. When these space rocks circle the Sun, their paths tend to be elliptical or very flattened, often exhibiting sporadic rotations and tumbling movements across the cosmos. The solar system is home to over 1 million asteroids, owing to the vast majority of these space rocks. Both are close to Jupiter, which as a gaseous giant has a strong gravitational pull. Under the action of this gravitational force, the orbits of these asteroids in space become unstable, causing them to fly in a random way. Sometimes it may come to the inner areas of our solar system, even areas within Earth's orbit. And scientists have long known about the existence of meteors and asteroids, but it wasn't until 2013 that a meteor hit Russia's Ural Mountains that people really began to realize the potential threat they could pose. The unexpected asteroid collision not only resulted in at least 500 people sustaining injuries, but also generated a shockwave. Blowing up a large number of windows and buildings, the meteor reached 18 meters in diameter and weighed 9,100 tons. Imagine the outcome if an asteroid, 27 times the size of the meteor that struck Russia, were to impact our planet. It is obvious that the impact will be huge, potentially leading to the fragmentation of continents and permanently changing the face of the planet. NASA has acknowledged the possibility that the asteroid Bennu might intersect with Earth in the year 2182. Although the current collision probability is 1 in 1750, this possibility still exists. Although it sounds like, for example, the risk of an asteroid colliding with the Earth is low, but in fact its collision probability is equivalent to twice the probability of finding a particularly precious gem, or more than 5 times the probability of being hit by a car. No matter how small the probability of these events happening, but these events do happen, although Bennu asteroid only caused the extinction of dinosaurs. 1/20th the size of an asteroid, but it's still powerful enough to destroy multiple cities, and left a vast cavity measuring 6,500 meters across, thanks to the ancient Bennu asteroid. It has always posed a threat to the living environment of the Earth, so NASA scientists have been paying close attention to this problem. NASA even sent a spacecraft to the surface of Bennu asteroid to collect samples to help scientists understand the composition of the asteroid. The OSIRIS-REx spacecraft executed this sample retrieval operation, having launched in the month of September 2016. A 2-year journey to the Bennu asteroid was undertaken before the spacecraft entered orbit in December 2018. The Bennu asteroid has been around for much longer than humans have existed. The discovery gives scientists the opportunity to study samples of Bennu's asteroid and get more information about the solar system from it. It is precisely because of the possible impact risk of Bennu asteroid. It became one of the most interesting research objects for scientists. The main goal of this mission is to provide insights into the origin of the universe and answer a series of questions about the origin of the Earth's atmosphere. Important issues, such as the origin of water and the origin of organic molecules that make up life on Earth. The probe spent 2 years on its way to Bennu asteroid, during which it mapped the surface of Bennu asteroid, until the mission team can identify a safe landing site and collect soil samples. Once the mission team identifies a suitable landing site, the OSIRIS-REx probe will land on the asteroid Bennu. He would then use his touch and advanced sample collection mechanism to collect a sample of the asteroid Bennu. Something unexpected happened when the probe landed. The original plan was to release nitrogen when the probe landed. The device will displace surface debris into the chamber designed for sample collection, storing these specimens for the return voyage to Earth. But landing on the Bennu asteroid isn't that simple. But when the detector actually touched the surface of the asteroid, the surface actually separated like a liquid, causing the detector equipment to fall into the surface of Bennu asteroid. When the gas was released, the disk of the probe had been inserted 10 centimeters deep into the surface of the asteroid Bennu. When nitrogen is released onto the surface of Bennu's asteroid, the gas pressure creates a diameter of about 8 meters meteorite. Additionally, gas release also causes the substance on the surface to shoot out in all directions, including towards the sample collection chamber. The minimum sample collection task requirement is 60 grams. However, because the detector encountered some unexpected situations during its brief contact with the surface of the Bennu asteroid, the detector finally successfully implanted 300 grams of samples into the sample container. Meanwhile, when the OSIRIS-REx mission returned to Earth on September 24, 2023, researchers discovered the samples from the Bennu asteroid contain a significant amount of water, locked within minerals like clay. Besides water, these samples are also rich in elements like carbon, nitrogen, sulfur, and phosphorus. Team researchers claim that by examining the isotopes in Bennu asteroid samples, they found these samples appear different from any other substances known in our meteorite collections. This discovery is exciting. After all, this is the first time that scientists have had direct access to samples from the Bennu asteroid. The collection of Bennu asteroid samples is indeed a major scientific achievement. But since the samples have been floating in space for a long time, they may have been contaminated by other space rocks, making it difficult for scientists to determine the exact origin of the samples. The mission of the OSIRIS-REx probe is to track the movement of the Bennu asteroid. By monitoring Bennu's orbit, scientists can assess whether Earth is at potential risk of collision. Based on early analysis, Bennu asteroid will approach Earth again in 2035. If this happens, its orbit will change due to Earth's gravity, potentially leading to a collision with our planet. But the threat doesn't end there. Scientists have calculated that the Bennu asteroid will pass through 26 gravitational keyholes. Any one of these gravitational areas could alter its orbit to align with Earth's trajectory. In this case, the chance of Bennu asteroid impacting Earth on September 24, 2182 is the greatest. However, in 2021, NASA revised this prediction and announced after further analysis that two of the most dangerous gravitational keyholes faced by Bennu asteroid, either of which could align with Earth's orbit, thereby increasing the risk of collision with Earth. If a collision occurs, will Earth face an apocalypse? Therefore, scientists are considering several methods to alter the orbits of those dangerous comets and asteroids to prevent them from hitting Earth. One proposed solution is a kinetic impact. This technique involves striking the asteroid with enough force to change its orbit around the Sun, thereby averting the threat. Our planet's encounter with an asteroid could be concerning, especially if the asteroid consists of loose debris. In such a case, utilizing kinetic impactors might be ineffective. An alternative strategy could involve employing gravitational tractors to divert the path of the asteroid. For this method, an unmanned spacecraft travels in proximity to the celestial boulder. It continuously monitors and studies its properties and orbit. This process can last for months or even years. To gain a comprehensive understanding of the space rock's nature and behavior. Over time, the probe's gravity alters the asteroid's path, redirecting it onto a new path away from Earth. The larger the probe, the stronger its gravity, and the faster the orbital shift. However, since neither of these technologies has been tested, we cannot be certain of their effectiveness. Moreover, we have another technology to defend against rocks heading toward Earth at the most dangerous moment. That is the nuclear bomb. We could design a rocket with a warhead to be launched from a conventional launch pad in a relatively short time. By detonating a nuclear bomb near the asteroid, enough force can be generated to change its orbit without directly interacting with the asteroid itself. This method can effectively reduce the damage to the asteroid and lower the potential threat to Earth. So, do you think humanity has the ability to change the catastrophic impact of Bennu asteroid on Earth in the future? Share your different views and opinions in the comment section. Thank you for watching, follow us, and see you next time.